Bore-da, people, Bore-da. Happy St. David's Day. Welcome to this celebration of some of the science around St. David and St. David's Day. My name's David as well, and I work for a company here, Science Made Simple. And in Science Made Simple, we got a great job. We work around Wales, we work around the UK, we work all around the world, talking to wonderful people like you about science, technology, engineering and mathematics. STEM subjects, you might have heard them being called that. Now, in the next 10 minutes or so, we ain't going to think about the science of these daffies. We ain't going to think about the science of these leaks, even though they're both full of science. What we're going to think about is something that's inside the daffies, inside the leaks. Big clue, you can see they're both sitting inside some of it as we speak. Water. You see, St. David, one of his nicknames is the water drinker. He was a monk, and so he ate a very simple diet and drank only water. Hence, you end up with a nickname like the water drinker. What we're going to do is have a quick look at the science of water. And so you might take this opportunity, you don't have to, but if you had some water nearby in a cup or a glass or something like that, now if you do get some of the water, try not to spill it over your laptop or your phone. That wouldn't be good. That wouldn't be. We're not aiming for that. So, and let's see what we can work out about this water with our senses. So, what does it look like? Well, I can see you. Okay, I can see the camera I'm looking at through the water. I bet you could see the bottom of your container as well. So water's clear, or as scientists might put it, water is colourless. What does it smell like? Let's give it a go. Oh, I got some water up my nose then. Sorry. Doesn't smell like anything, really. So it's odourless. It has no smell. And last but not least, I'm going to taste it. Now, only taste yours if you've got clean drinking water. Okay, let's be safe. Tastes like water, doesn't have a taste. It's tasteless. So we've got a colourless, odourless, tasteless, and at room temperature, like I've got in here more or less, it's and I'm sure you have at home or wherever you are at school, we've got a liquid, well said. Great. We've used our senses to get what information we can from water. But what's it made of? Well, I've got a model here of what water is made of. Look at this. H2O, a water molecule. Right? Now, if I tried to chop water into any smaller bits, it wouldn't be water anymore. This is the smallest bit of water we can still call water. Such an important word. I'm going to say molecule, and you're going to say it with me. Molecule. Yeah. 2 hydrogen atoms, 1 oxygen atom. They're put together in this shape, a water molecule, and the way they're joined together through hydrogen bonding, one molecule to another, gives water lots of the amazing properties that we use every day, which is what makes water so incredible. And that we're going to have another look at in a second. Okay, we've looked at water, we've worked out what it's made of. Well, what else can you do with it? Well, does it conform to like the pushes and pulls and forces of our everyday lives? Let's give it a go. Got a bit of kitchen towel here. I'm going to see, does water work with gravity? Missed the kitchen towel, would you believe? It does. Forces produced by gravity work on water. Great. Now, what about... Hopefully you can see the water moving. Splash my face. I can use a straw as well to blow and suck. And so with wind and with blowing and sucking, we're talking about pressure. So air pressure, one way or another, can affect water. If I get my straw again, you could try this with a straw or a pen or your finger. I'll put it in here and stir. And hopefully you're going to see it's spinning round. We've got a bit of a tornado. What's that lovely sciencey word to describe that swirling whirlpool of a thing? A vortex. Yeah, vortex science. So vortex, we can do that to water. We can even, maybe you can try this with your container, as long as your container's big enough to get your hand in. I'm going to get my fingers like this and dip it into the water. Oh, it's cold. Oh. You see? Now, you might think, oh, well, we're squeezing the water. It's really difficult to squeeze water. Water is one of the strongest things in science. Really difficult to squeeze water. But what we were doing was moving the water out of the way. My fingers went in, and did you notice? And I'm sure that'd happen with your container as well. The level of the water went up. We were displacing the water, moving it out of the way. Oh, you can do so many things with water. And we're going to think about another one as well. We're going to do a game of scientific observation. Your observation. I've got 3 cups here. I'm going to put some water into one of the cups. Which one? We'll start off with this end one here. I'm going to start doing the old switcheroo game, moving these cups around. And you've got to follow the water. I mean, you know the water started here. You had evidence. You saw me pour the water. Here we go, slowly at first. And then I'm going to want you to tell me, woo, which cup the water is in. That was close. Okay, you're saying this cup. You're saying this cup. Not many. So you're saying the middle cup? You sure it's not this one? Okay. And you're absolutely right. It's the middle cup. It's the middle cup, people. I'll pour it in here so you got it. You were right, people. You're good at this. This time I'm going to go a little bit faster. Here we go. Where does the water go? Trying not to spill it. That would be unfortunate. But a little bit faster. We can move and move and move and move and move and move. Okay. Now you're saying the water's in here. No. You're saying the water's in here. No. Are you telling me? Oh. Are you telling me the water's in here? Sure? You got it in here. You got it right again, people. You got it right again. One last time, fastest of all. This time I'll get you. Water goes in there. And we start moving it around. Fast as we can possibly go. Where is that water going to stop? Saying water in here. Not many hands up. You're saying water's in here. Not many hands up. You sure? Sorry, just being silly. Which means the water must be in here. Oh dear. Oh dear. No. You told me the water was going to be in this cup. It's not. It's this is your fault, people. 3, 2, 1. David's still dry because I tricked you with a piece of science. If you look inside that cup, hopefully you can see. Looks a bit like ice. It isn't ice. If I move my cups out of the way and put my hat back on, you can see that we soaked that water up, we absorbed it. I'd put some powder in the cup before we added the water. And that powder, I can never spell this word, that powder is called sodium polyacrylate. Sodium polyacrylate. And it's fantastic at soaking things up, at absorbing liquids. I think it can absorb nearly 1,000 times its own volume in liquid like water. Really, really absorbent. Now, you might have met sodium polyacrylate before and not realised it. Because if you ever wore one of these, a disposable nappy, or you've got baby brothers and sisters, or baby nephews and nieces, or some of your friends have babies, then these are full of sodium polyacrylate. In the core, the substance that's really good at soaking up and absorbing the liquids that babies make, it's sodium polyacrylate. With your teachers or with your mums and dads, what you might do is get one of these, stick it in a wash basin and slowly add water to it and measure how much liquid they can soak up, how much liquid they can absorb. It's really a lot. It's a lot more than I first suspected. So there you go. There's something we can do with water. We can absorb it. Now, Saint David loved water. It was really important to him. All those hundreds of years ago when he lived. Water's important to us today, to us and nature. Really, really important. Water's going to be needed and really important in all our futures. Water is one of the basic building blocks of life.
For more videos exploring science and engineering ideas, find us on Facebook and subscribe to our YouTube channel at Science Made Simple UK.